Hello everyone. Today I'll take you guys through the journey on the data of Kansas City to understand how it is growing and evolving. We'll be using data mining to turn thousands of building permits into a clear story about the urban development in Kansas City. So my research question was, how does residential construction investment vary across Kansas City, and what is its relationship to the new housing supply? We'll be sorting our data, or we'll be getting our data from the building permits from Kansas City's Open Data KC portal. So the significance of this project was that permits are a real-time pulse of urban growth, informing policy on housing, infrastructure, and equitable development. Our central question is simple but powerful. Where is Kansas City's building, and what does this tell us? We used the city's own public data on building permits. This isn't paperwork, it's a gold mine of information that can help planners, policymakers, resident makers make smarter decisions about the city's future. Now we used, in the project, I used data mining toolkit, Python with pandas for data cleaning, and skitlearn for machine learning. The challenge here was that the data was a bit messy, requiring some conversion, cleaning, and standardization. For the city's wide analysis, we would need distributed computing like Apache Spark to handle the scale. To tackle this, we used Python. It was perfect for the heavy lifting of data cleaning, converting texts to numbers, handling missing values, filtering for what we needed, specifically new residential construction permits. We also identified that for a truly city-wide historic analysis, more powerful distributed computing tools would be essential. The method we used and finding patterns with K-means clustering. K-means clustering and unsupervised machine learning algorithm automatically group council districts based on their development profile without any preconceived labels. Total investment permit, which is the permit value, versus the housing supply, which is the dwelling units that was added every year in the Kansas City district. Our key analytical technique was K-means clustering. Think of it as a smart algorithm that looks at it at all the districts and then naturally groups them based on how much they are investing and how many new housing units are added every year. We will let the data tell us the story rather than forcing it into categories we invented. So these are the key findings. Finding number 1, 3 Kansas cities. The algorithm reviewed 3 distinct development profiles: massive investment, large-scale projects. That's the cluster 1. The cluster 1 actually had high investments or high growth in 3 districts. So the massive investments and large-scale projects. Cluster 2 had moderate investment to steady growth in 5 districts. Consistent mid-level construction activities was on there. And cluster 3 had low investment, limited growth. It also had 5 districts, minimal new residential development in cluster 3. And here's what the data told us. The algorithm clearly identified 3 Kansas cities within the city. First, we have the very high investment, high growth districts. That's the powerhouses of new development. Then we have the 5 moderate investment districts with steady activities going on. And finally, we have the 5 low investment districts that are seeing very little new construction. This uneven landscape is the core of our finding. Finding number 2 was the investment geography. You understand that investment is not evenly distributed per our analysis. The top districts receive a disproportionately large share of development capital. Strong correlation exists. More investments generally means more housing units. Drilling deeper, the ranking of investments by district visually confirms this concentration. A small number of districts are attracting the bulk of the construction dollars. We also found a strong correlation where investment is high, The number of new housing units is also high. This seems obvious, but now we can quantify it. Our third key finding we found was the spatial pattern. We understood from the analysis that development is spatially clustered. The high growth areas are likely linked to existing infrastructure, policy incentives, or market trends. This creates a clear map of hot and cold zones for development. So some areas would have a lot of development going on, and some areas would barely have nothing. Perhaps the most compelling finding is the spatial one. When we map these clusters, we don't see a random scatter. We see a clear geographic patterns. High growth districts clusters together, suggesting that factors like transportation access or specific zoning policies are creating development hotspots, while other areas are left behind. So from our insight to what policymakers should actually do, for our insights to actions, that's the policy implications. For high growth districts, analysis tells us that policymakers should actually manage growth pressures, ensure affordable housing, invest in infrastructure. For the low growth districts, they must also stimulate investment with incentives and target revitalization programs. For all of this, we use this data-driven approach to replace guesswork with evidence in urban planning. So what does this all mean? It means we can move from one-size-fits-all policy to a tailored strategic approach. In high growth areas, the city should focus on managing that growth responsibly. In low growth areas, a goal should be to stimulate investment. This analysis or this project actually provides the evidence base to make those decisions effectively and equitably. In conclusion, and for future work, we successfully transformed raw permit data into a clear understanding of cases development landscape. The contribution is a reproducible framework for data-driven analysis that anytime the city planners, policymakers need, they can go back to it and make further analysis on as the year goes by and as the city grows. So we incorporate time series analysis, more data sources like census data and predictive modeling in the future. So if the policymakers need to, in the future, you just incorporate more time series analysis, which would actually broaden our analysis base and give you year by year what they need to do. In conclusion, we've shown how data mining can turn municipal data into a powerful tool for urban insight. This isn't the end of the story. Future work could look at trends over time and incorporate data on affordability. The key takeaway is that our cities are speaking to us through data. We just need to learn how to listen. Thank you, ladies and gentlemen. All the best and best regards.